right, last section of the chapter 2.8 is on graphing two variable inequalities. So what we're going to be doing is looking at graphing lines, but they're going to have inequalities. So you'll have to do some shading, and you'll have to decide whether or not the line is dotted or solid. We'll also be graphing absolute value functions with less than, greater than, less than, equal to, greater than, equal to. So kind of combining what we've been doing here this chapter, only now we're going to be doing some shading because we have a lot of different answers that could work for a certain problem. So I start you off with a word problem that hopefully makes sense to you. You're going to throw a party and you're going to provide hot dogs and hamburgers. And we're going to go with hot dogs are $2 a pound and hamburgers $3 a pound. But you only want to spend $60. So there's some limitations here. You couldn't say, oh, I want to get 100 pounds of hamburger because you don't have enough money. You'd have to have $300 for that. So the limitation is $60. So we're going to graph all the different possibilities of what you could get for hot dogs and hamburgers based on the restrictions that are given. When we get to the graphing part, you can see I've got inequality. You're going to use a dotted line when you have less than or greater than, and then you're going to use a solid line for less than, equal to, greater than, equal to. Dotted means that points on the line don't work. Everything up to that line works, where solid is if you're a point on the line, that's going to work too. So trying to come up with a solution for above. I've got a section down low here for variables. Try to identify what your variables or how many variables you have and what they stand for. In this problem up here, there's two things I want to find. So I can call those X and Y. The two things I want to find is the number of hot dogs in pounds and the number of pounds of hamburgers. So those are my unknowns. Variables go in place of unknowns. So I would say pounds of dogs, hot dogs, and pounds of burger. Well, if you get stuck on any word problem, I would say pretend that you're going to go to the store and you're going to buy something. See what math you would do. So I'm just going to pretend, I'm going to say, all right, I think I'm going to have 5 pounds of hot dogs and 4 pounds of hamburger, just as a guess. That's my pretend answer. So if I wanted to get 5 pounds of hot dogs and 4 pounds of burger, I'd say, all right, 5 pounds of hot dogs. Well, how many is it? What is it per pound? It was 2 per pound. So I would do 5 times 2, and that would be 10. I'd spend $10 on hot dogs, and I think most of you should be comfortable with that, right? Well, how about the burger? For the burger, it's 4 pounds, and that's $3 a pound. So I'd spend $12 there. And then I go to the cash register, and they total it all up, and I find out, hey, I just spent $22. Well, that's all I really need to know how to do in order to set up an equation or an inequality for this. I replace the guesses with the variables. So I guessed 5 pounds. So I'm going to use that for example. Well, 5 isn't given. 5 stood for the pounds of hamburger, so what am I going to put in place there? X. So it would be X times 2. Well, I wouldn't write X times 2. I'd put 2X. Same thing over here for the hamburger. I guessed 4 pounds of hamburger, but that was really a guess. What goes in place of pounds of hamburger? Well, I decided that'd be Y, so it'd be Y times 3, but we're going to write that as 3Y. You add those together, and that needs to be your total. Well, I give you a total. The total was supposed to revolve around 60. So I could put equals 60, but that would be a mistake. Because it says I have 60 to spend. It didn't say I had to spend all 60. So this could be 60, but it also could be less. So my guess over here was valid. This was something that would work, 5 pounds of hot dogs and 4 pounds of hamburger. That would work, but there are many other things that could work as well. So this is what I want to graph. 2x plus 3y is less than or equal to 60. I'm going to label my axes here. Again, x stood for pounds of hot dogs, or hot dogs in pounds. And then this up here was pounds of burger. Slide this over a little bit, okay? So how would I go about graphing this? Well, this is in standard form. And I talked about graphing in standard form. The easiest way being just find the intercepts. Plug in x is 0, plug in y is 0. If I plug in x is 0, I get 60 divided by 3 is 20. Don't worry about the less than equal to or the less than. Don't worry about this. Some people get hung up thinking they need to come up with something that's smaller than 20 and put that in for their y-intercept. We're going to deal with this, this inequality symbol later when it comes time to decide if it's shaded or dotted. We're finding the intercepts just like we did for an equals. We're going to go 60 over 3. That gives me my y-intercept, which is 20. Change that back here. So my y-intercept was 20. Now if I let y equals 0, that's going to cross this out. And I end up having to do 60 divided by 2. Not worrying anything about that less than. I just need to know a boundary point, and that would be 30. So those are what I need to graph for intercepts. I need 30, 0, and 0, 20. Well, now I got to come up with 30, 0 over here. I don't know how many marks I have. I got 2, 4, 6, 8, 10, 12, 14, 16, 18. There's 20 there. And I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 there. So I'm going by 20s. I'm going to go up by the same amount. So seeing as 1, I need the x's to go out to 30. I guess if I went by 2s, would that be comfortable? I can't go by 1s because I only have 20 spots, actually 21. But let's go by 2s. So if I go by 2s, then this would be 4, because it's 2 spots. This would be 8. It's like going up by 4, 16, 20, 24, 28, 32. 30, 0 is right here. And let's do the same thing here. Let's go 4, 8, 12, 16, 20. 0, 20 is right here. Now what I need to do is draw a line that connects. So it's actually a segment. I wouldn't want to draw a line because I can't have negative pounds of hot dogs nor negative pounds of burger. So I'm going to draw a segment between those two. And that segment is going to be solid. It's going to be solid because of the fact there's this equals underneath here. So again, when you have less than equal to or greater than equal to, that's going to give me a solid line. If I have less than or greater than, that's going to give me a dotted, or I might say dashed line. Now I need to find which way to shade because there's other solutions that work. Here, everything on this line works. If I find a point on this line, it looks like this is on the line. My line isn't exactly perfect, but it looks like this point is on the line, 26, 2. That should work if it is on the line. If I plug in 26, I get 26, I get 52. 2 times 26 is 52, and then 3 times 2 is 6. Those add up to 58. I'm just plugging in the coordinates 26, 2 into 2x plus 3y. So I'm doing 2 times 26 is 52, and 3 times 2 is 6. That's 58. That's less than or equal to 60, so that's a possibility. Now on my graph, it looks like that's on the line, but that's because my line is a little bit off. I should move that up a little bit. And hard to do this perfectly. Come on. Well, I have to call that good enough. But now I can see that 26, 2 is actually below the line. Okay. Is there a point that looks to be on the line? How about this one here? 12, 12 looks like it's on that line now. Let's see if I got my line in better shape here. What if I plug in 12, 12? I'd have 12, 12, 2 times 12 plus 3 times 12. That'd be 24 plus 30, 60. That's 60 perfectly. So if you get the line drawn correctly, the points on the line will work. They work because it could equal that amount. I could spend exactly $60. Okay? But I also could spend 58. And this point, 26.2 right here, that's inside the line. That works. So you're going to shade inside the line. Everything inside is going to work. That's how that operates there. So I just shade that. Normally I'd say just plug in 0, 0, but I already plugged in the point 26.2 to come up with the direction you shade. If you plug in 0, 0, you end up with 2 times 0 plus 3 times 0. Well, that's just 0. That's why I like to plug in 0, 0. And we want to know if that's less than or equal to 60. And it is. So you shade towards that. Because this point works here, you shade towards that. So it was a shade in situation. If you would have picked any number outside, you decided, hey, could I get 30 and 6? You plug that in, it won't work. So you can't shade that. If you plug in 30 and 6, you'd end up with like $78 spent. So this is a word problem that leads to what we're doing today. If I wanted to be a shopper and come up and plan for this party, I could pick anything in the red shaded region here for a value. I could get 9 and 4. That's going to work. I could get 12 and 10. That's going to work. Anything inside there should work. Okay, so how do we do this just without a word problem? I got y is greater than or equal to 4 minus 3x. That's almost in slope-intercept form. So I would just graph this by using the slope and the y-intercept. The slope is -3, the y-intercept is 4. So I go up 4 for my y-intercept. I go down 3, 1 right, down 3, 1 right. Because there's a greater than equal to, I need a solid line again. That is not a good line. Let me try that again. Probably better off just activating the line. Okay, so there's that line there. Now I need to decide which way to shade. I can plug in any point that's not on that line. 0, 0 is definitely not on that line, so I'm going to plug in 0, 0, which would give me 0 is greater than or equal to -3 times 0 plus 4. 0 is greater than or equal to 4. That's false. Therefore, this point 0, 0 is not supposed to be in the shaded region. So we need to shade away from 0, 0. And that means we shade this side. Everything over here works. So if I want to come up with a possible solution, I could pick anything that's over here. 3, 0, 4, 1, 5, 3. Anything over in this blue region is an answer that works for my initial function. 4, 1 minus 3x is less than 15. That's almost standard form. Standard form would be if I had the x in front. Don't really need to rewrite it in standard form. I'm just reminding what standard form is. When it's in standard form, I really like to go with the intercepts. If x is 0, crosses that out, I do 15 divided by 4. I don't worry about the less than. I just do 15 divided by 4. 15 divided by 4 is 3 3/4. That's my y-intercept, 3 3/4 up. Let's plug in y is 0. This one works out a little bit nicer. I get 15 divided by -3. That's -5. I don't worry about the less than. I just go graph my -5. Now I get to decide what kind of line. This one has a less than with no equals under it, so points on the line won't work. So I have to use a dotted line to make my graph. Now I need to decide which way to shade. Do I shade towards 0, 0 or away? If I plug in 0, 0, everything on the left cancels. You know, if I plug in 0, 0, I'd have 4 times 0 minus 3 times 0 is less than 15. I get 0 is less than 15. That's true. So we're going to shade towards 0, 0. So we need to shade, this point needs to be in there, so we shade down. Something that'll happen if you happen to get the y alone and you get into a situation where it's y is less than, that tells me shade down as well. Up above, y was alone here. It said y is greater than, so I need to shade up. See how this went up right? If I was going to describe this direction, it'd be up right. This over here would be down left. Okay, this is down left of the line. This is up right. It says y is greater than right here. So I need my y's to be bigger. Y's are bigger on the upright side. Example 3. This one doesn't have an x, so as a mathematician, I know this is a horizontal line. I'm going to get the y alone. Now, keep in mind, if I divide by a negative, that switches this over, so it's y is greater than -2. It's a horizontal line, 2 down. It's dotted because it doesn't have an equals, and where is y greater than -2? Well, this is a y that's greater than -2. Y is -1 right there. Here's a y that's greater than -2. Y is 1 right there. Where are all the y's greater than -2? Everything that's up here. So we shade everything that's up. Okay, this is another one caused a little bit of issue. This has an x and a y, so this one's going to have some kind of slant to it. How would I get it? I'd probably get the y alone on this one, which will turn into 1/2 x is greater than or equal to y. If you weren't comfortable looking at it that way, you could rewrite as y is less than or equal to 1/2 x. Both of these are pointing at the y. See, they're pointing the arrow at the y, and they're pointing the arrow at the y. So this is basically in slope-intercept form where the intercept is 0, 0, and the slope's a half. So I'm going to go up 1, 2 right, up 1, 2 right. I can go down 1, 2 left, down 1, 2 left. This one's going to have a solid line because it's got the equals. And the tricky thing about this one is I can't plug in 0, 0 because it's on the line. I'd have to plug in something else. Or I just recognize that it says y is less than. But if I had this facing the wrong way, this inequality symbol, I'd get it wrong. So here it says y is less than. I know that y would be less than over here. This is down and right. Otherwise, on the other side, it would be up and left. So I want y's to be smaller. I want them to be down. So I'd shade down right. Otherwise, you could pick any point on here, whatever you want. You know, I could pick 1, 2, plug it in, see if it works. Let's take a look at that, 1, 2. I'm going to plug that into the initial function. So it'd be 5 times 1 is greater than or equal to 10 times 2. And you're trying to make the claim that 5 is greater than or equal to 20. That's not true, so that's not part of our solution set. So that would tell us that we have to shade down here as well. Another way to get that shading. Okay, here we have absolute value. So this is a reminder of absolute value. When we do absolute value, we make a V, we find the vertex. This -2 tells me our vertex gets shifted to right. and that tells me it goes 3 up. So our vertex is at 2, 3. And this is our slope, negative 4. So I'd go down 4, 1 right, down 4, 1 left. To do that again, so I get a good V. Because of the less than, and it isn't less than or equal to, we're going to have a dotted V. And then we got to decide, are we going to shade in the V or outside the V? Well, it says Y is less than, so I have a pretty good idea that Y's are smaller inside because, I guess this is kind of hard to describe, but the Y's are going to get smaller here. This each side this side kind of blocks everything off over here, keeps it up above, so to speak. So these points over here are definitely lower than these points over here. Otherwise, plug in a point. It sure looks like I could plug in 0, 0 on this one, but you know what? I don't want to. What looks like it'd be better to plug in this one would be whatever makes the inside of this expression equal 0. So I'm going to plug in x is 2, and I'll let y equal 0. So you see what happens if I plug in x is 2? I end up getting this absolute value part to cross out. I skipped a step, negative 4. The absolute value is 0, 0, negative 4 times 0 is 0. And I end up with 0 is less than 3. So that's true. So 2, 0 needs to be graphed. Needs to be shaded. And 2, 0 is right here, and that's inside the V. So that's another way to tell me, hey, you got to shade inside the V. Oh, it's kind of a tricky looking one here. We're going to have to get y alone, so we're going to minus the 2. I have to get rid of this negative, so I have to divide everything by negative 1. When I divide by a negative, that switches my symbol. Here, that just simply makes it a positive 2x plus 1 and becomes a minus 4. This is one of those tricky problems where we had a number in front of the x. You can't just say the vertex is at negative 1. This is one of those where we said, well, I'm going to have to take a 2 out. And then 1 divided by 2 is a half. Now I can do absolute value of 2 and put it on the outside as 2. X plus half stays inside, minus 4. So the vertex is actually negative a half, negative 4. The slope is 2, so I'll go up 2, 1 right, up 2, 1 left. Up 2, 1 right, up 2, 1 left. I'm going to make my V. This V is going to be solid because of the greater than or equal to. And which way do I shade? I'm going to plug something in. Again, I like to make the inside equal 0, but I don't know, that would be kind of tricky. I'd like to go back to the original, but because it's 2x, I'm just going to plug in 0, 0 on this one. Looks like 0, 0 might be just as easy as anything else. So that would give me 2 minus 0, because y is 0. Negative here, 2 times 0 plus 1, absolute value, plus 6. So 2 minus 0 is 2. This ends up being negative absolute value of 1. So that is negative 1. Negative 2 is less than or equal to 5, which that is true. Therefore, the point I plugged in, 0, 0, I plugged in 0, 0, has to be graphed. So I shade in. Now when I have the y alone over here, that also shows me to shade in because I ended up with y is greater than, and where are y's greater? Up. And if I were to look at a side here, right here, there's a side, the points inside are higher than the points outside. Okay, I can get higher on the inside than the outside. Okay, finally, kind of long lesson today here. Finally, let's, it's actually a 2-day lesson. Let's come up with our own inequality. So here I have a line. When I come up with the equation of a line, I'd like to identify the y-intercept and the slope. And this one looks like it goes here. So my slope looks like it's 3 down, 1 right. So that'd be a slope of -3. So normally I'd be thinking y equals -3x plus 7. But it's not equals because we have shading. So what is it? Well, it's either less than or greater than because it's dotted. Now the question is, which one is it? Well, this is where it's going to be helpful to realize that these points are up right and these points are down left. And we want the ones that are up. And up means y has to be greater than -3x plus 7. If you're struggling with that, I would take a point like 0, 0, plug it in and make sure what you wrote is true. So if I plug in 0, 0, I get 0 is greater than 7, which, wait a minute, that's not true. So what is the problem with this? 0 is not greater than 7. Oh, there is no problem. I plugged in 0, 0. What kind of statement do I want to get? See, 0, 0 is not in the shaded region. So I want to get a false statement. Now I'll pick something in the shaded region. Looks like 3, 0. Plug in 3, 0. And you get 0 is greater than or equal to -3 times 3 plus 7. 0 is greater than -9 plus 7. You get 0 is greater than -2. That's true. So you see what I did there? I came up with my inequality and then plugged in a point. If I pick a point that's outside, it better be false. If I pick a point that's inside, it needs to be true. And it is. So I'm very happy with my y is greater than -3x plus 7. Okay, finally, I got an absolute value one. To do an absolute value one, I need to identify the vertex. And the vertex is at -2, -3. In order to do a -2, I add 2 to an x. That gives me that shift of 2 to the left. And I get -3 on -3 at the end. Now all I need is the slope. I think my intent was to have this point and this point be on the graph. So that looks like I need to go up 3 and 2 right, or up 3 and 2 left. So that's my slope. And then I'm going to have y is something with an equals, because the lines are shaded, they're full, they're solid, they're not dotted. And then what do I want y to be? Well, y's are getting higher here. So I want y to be greater than or equal to. Again, you could check a point in there. You could plug something inside here, maybe plug in -2, 0, and see if it's true. You'd get 0 is greater than 3/2, -2 in there. I plugged in -2 because what that does is basically cancels all this out, because that'd be all 0. And then you get 0 is greater than or equal to -3. And that's true. And that's what I wanted. I picked a point inside. I plugged it in. I got a true statement. So I'm very comfortable with my final answer. Thanks for watching. Have a great day.